So how might we prevent sensitive source code from being worked on personal devices? A lot of companies have sensitive code. They have sensitive code base. They use Git. How do we keep people from using Git on their personal devices? This is not a straightforward thing to solve. So we've been thinking about this as a small step as we lead up to the RSA conference here in San Francisco next week. And we're going to demo this at AppSec Village, but I want to show it to you right now. So we wrote an open source package, and we started with this idea that a lot of Git servers use SSH. And so when you're using SSH, you've got a few different key types to choose from. One of the key types is the SK key type, and SK stands for security key. When you generate a key pair with a SK type, you get an ID, you do get a private key file, but this isn't actually a private key. This is just a reference to the YubiKey, and the private key itself is stored on the YubiKey. It's not exportable. You can't get it out, and that's great because it means that anyone using this key is going to be in possession of the YubiKey. So it's like a user authentication thing because it's people are carrying around the key. It's something they have, but this could potentially be reused for device authentication. If the private key was stored on a TPM or a secure enclave or some other kind of secure element, it would be a similar kind of workflow. The problem here, though, is that you don't actually have any cryptographic proof from the server side that's looking at this key. You don't have any cryptographic proof that this key is actually stored in hardware, is not exportable, is even on a YubiKey or anything else. You could simulate a security key. There's a project called Virtual FIDO that lets you simulate a security key, and you could generate one of these SSH key pairs, and it would look to the server like it's on the security key, but it's just a file on disk. So that is one of the issues. If we could actually have cryptographic proof that a key is stored in a particular secure enclave or TPM or on a YubiKey in this case, just for the demo, that would really change the situation in terms of the security properties, right? It would make it so that you can only access that Git server if you are actually coming from a device that the company knows about. Now, the reason this isn't already part of SSH is for privacy, right? So SSH protocol doesn't include this information, this cryptographic proof, also known as an attestation. It doesn't include this attestation information in the protocol itself, in the handshake, when you're signing into a server for privacy reasons. But for corporate-owned devices, I feel like the trade-offs are a little bit different, and it can be acceptable to include the attestation information, especially because the company already owns the device. They know what the serial number is. They know the identity of the device already. And this is one way to ensure that, like, hey, this is actually a device I own, right, that is being used to access the Git server. So what we did was we took that attestation information. That attestation information, by the way, is actually generated by SSH keygen. First, I have to make a challenge file that's just like a random 128 bytes. And then I can use SSH keygen and I can write out not just the key pair that I just showed you, but also this attestation information that includes an attestation certificate. So I'm going to do that right now. The attestation certificate was saved, and that certificate actually ties back to, in this case, Yubico's FIDO root CA. So I can verify that if I have this attestation information, I can verify that this key that I just generated is actually on this YubiKey with the serial number of my YubiKey, right? So I have much more of a rich set of information to work from. But since this isn't part of the SSH protocol, we had to figure out how to sneak it in. So what we decided to do is write a program that adds a custom extension to an SSH certificate. And that custom extension includes all the attestation information. So let's take a look at that. I'm just generated a certificate using the same key, SSH certificate, and I included the attestation information. This is using our open source tool. So here's the attestation information. you can see like normally a SSH certificate would have all these extensions. We've added this custom extension, and this is like a base 64 of the entire attestation certificate. And we just gave it a name, SSH-SK attest01 at step.sm. And we also wrote a verification program that can verify, given the Yubico FIDO certificate authority that signed the attestation certificate, and given my certificate, the certificate that I just created, can verify that indeed this attestation information is valid, it chains up to the Yubico CA, and it is linked to this public key. So much stronger guarantees of what's going on here. And what we do is we use this in practice. We're using this on, I have an Ubuntu virtual machine here, and I'm using it as an authorized principals command. So this verification code runs here when a certificate is presented to the server, and it checks to see that the custom extension is there and is valid, and then we can get into the server. So let's SSH and see. So here we're gonna SSH in. I have to touch my YubiKey. We've offered the certificate here, and I'm in. And if I look at my log on the server, we can see that the attestation was successfully verified for that certificate, right? If I were to try to sign in with a certificate that doesn't have that custom extension, I would not be able to access the server. So that's the demo. Thanks for watching, and let me know in the comments if you have any questions, thoughts, ideas, and I will also put a link down below to the GitHub repository for this project. All right, thanks.